Hello everyone, my name is Dr. T.S. Kurne, Department of Statistics, Rajarshi Chhatrapati Shahu College, Kolhapur. In this lecture, we will discuss the second design named as randomized block design. It is noted as RBD. It is also called as a two-way classification because here we have used two factors. In CRD, we have used only one factor like treatment, but in this design we have used two factors, treatment as well as block. If the experimental unit or area are not homogeneous, then we cannot be use completely randomized design. For this comparison of treatment, all the three principles of design which are replicated, randomization and local control are used in the randomization block design. Consider a set of V treatments to be applied of an experimental material having heterogeneity along one single direction. In this case, divides the experimental material into groups or strata. These are called as a blocks, and the blocks are performing perpendicular to the direction of heterogeneity. Hence, there should be homogeneity within the block and heterogeneity between the block because the blocks are perpendicular to the direction of heterogeneity. Now divide each block into the number of plots which is equal to the number of treatments, and each block is subdivided into V plots. Now allocate all the treatments over the block randomly. So number of plot is how to decide how many plots, the number of treatments we will apply, then you use number of plots. Use separate randomization for each block. In this design, all three principles of designs of experiments are used. Each treatment replicated once in each block. Hence, treatments are replicated b times. If the number of block is b, therefore the principle of replication is used to allocating the set of treatments randomly over the blocks. And the principle of randomization is implemented, and the experimental area is divided into homogeneous block for the purpose of removing the heterogeneity. Hence here principle of local control is also used. So now next we see the layout of this design. The V treatments are allocated at random to the V experimental units in the block, and the random allocation can be made by selecting a random permutations numbers. So let's see the example. There are the 5 treatments, each replicated 4 times. Then the total experimental unit is 5 4s are 20. These 20 units are divided into 4 blocks which are initially homogeneous, and each block contains 5 units because here treatment is 5. So number of plot is equal to the number of treatments, and number of block is equals to number of replicates. Suppose A, B, C, D, E be the 5 treatments, each replicated 4 times. Then the diagrammatical allocation of these treatments are as follow. These are the blocks and these are the treatments. Means in each block we have now divided into the plots. Now we see the next mathematical model of RBD. It is Yij mu plus alpha I plus beta j plus epsilon ij. Here only beta. In CRD, from the CRD extra included is beta j for the block for the RBD. In CRD the mathematical model is mu plus alpha I plus epsilon j only, but in RBD there is an extra term beta j. This is for the block. So similarly, same as the CRD, Yij is the yield, total yield, mu is the mean effect, alpha is the effect due to the treatment, beta j is the effect of jth block, and epsilon j the random effect. Assumptions are the same as as the assumptions in CRD. Only is the different effect like additive in nature. So in this design we have used some notations like yi dot bar is the mean response of ith treatment. Y dot j bar is the mean response due to the jth blocks, and this is the total for the treatments and total for the blocks, and overall mean is y double dot bar, and this is the formula for overall mean. Thank you.